Far out to sea, something goes horribly wrong. It can be a crossed wire that ignites a fire, an unexplained attack by submarine or anti-ship missile, a sudden and unexplainable blast deep in a ship's belly, or as in the case of the USS Forrestal, it could be a stray rocket causing an accidental explosion. It is hard to imagine a more hostile environment in which to confront an emergency than a modern warship. At sea, there is no place to run, nowhere to hide, no one to turn to for help. On a warship in trouble, there is no choice but to stand and fight. May 17, 1987, an Iranian fighter jet launches 2 Exocet missiles at the U.S. frigate Stark. Early warning systems aboard the Stark and nearby aircraft fail to alert the ship, and all defensive efforts come too late.
When the first missile hit, I wasn't exactly sure what had happened, and then I was up on top of the ship above the bridge. Then I stood up, and another person with me, the lookout, told me what it was. I saw the second one coming, and it's pretty terrifying.
One missile ripped a 10 by 15-foot hole in the hull, stopping fatefully in the crew's sleeping quarters. The other sliced through the superstructure of the ship. 37 crew members lost their lives.
The hazards to our men and women in uniform in the defense of freedom can never be understated. The officers and crew of the USS Stark deserve our highest admiration and appreciation.
Though crewmen did an admirable job keeping the ship afloat, the fire brought to light serious deficiencies in basic damage control preparedness. Doors and hatches that should have been watertight weren't. Hoses that should have worked didn't. For the Navy, it was a lesson hard learned.
I can't tell you how important it is. Until something like that happens, you never realize how important it is to understand what's going on, what to do, what you need to use.
By their very nature, Navy ships are potentially hazardous places. Chemicals and structural materials kept safely distant in the civilian world are common on warships. Jet fuel, ammunition, and high-voltage electrical systems are jammed into tiny spaces with living quarters. And the last place in the world you want to fire is near a nuclear propulsion plant.
Declutched 1 Bravo.
Sailors not only have to be technical experts in their particular jobs, they have to be amateur chemists as well. They have to know and avoid elemental chains of events that can start a fire, and if the fire starts, what chemical combination can put it out. When a fire breaks out aboard ship, the first problem becomes identifying what type of fire it is. This Navy training film teaches sailors the proper way to identify and fight a fire. Class A fires involve solid substances, wood, cloth, paper, or things that usually leave an ash. Class B fires involve flammable liquids, the lubricants, fuels, and paint found on every Navy ship. Class C fires are fires in electronic or electrical equipment. Finally, Class D fires involve combustible metals like magnesium and sodium, which are used in certain parts of aircraft and missiles. Some of the chemicals used to extinguish shipboard fires can be as hazardous as the flame itself. Carbon dioxide, or CO2, dilutes the oxygen content of the air, literally starving the fire, but it also displaces the oxygen in human lungs. Without proper protective equipment,